Okay, so what we're going to do from here on out, there'll be videos of all this stuff, so if you're sick, if you go online that night and you go on YouTube, if you look up my name and then you take the name of the section, and search it under my YouTube account, you can pull up what we did in class. So this is section 4, properties of special parallelograms. That's what that's going to be titled in the YouTube account. Now, as we progress, there are formal videos of other sections and chapters that we're going to do, but I'm also going to put in a video of what we actually did in class. Okay? So, in case you're sick, if you really want it, if you get a chance, and you're feeling better, or if you're on a field trip, then you can still watch that video that night, skip through the things you don't really need to watch, and watch the things that are necessary to go from there. Okay? Remember, if you're not here, you are to actually do the assignment. Okay? Alright, having said that, this is a thinking section. And it seems kind of easy at first because you're just dealing with a rhombus, a rectangle, and a square. But there's lots of little pieces that go into it. Okay? And you got to think about what each definition is. So in a rhombus, you have 4 sides that are congruent. Well, in a square, you have 4 sides that are congruent. So is a rhombus a square? Sometimes. Is a square a rhombus? Always. Square is always a rhombus. It has 4 perfect sides, right?
Yep.
But that is definitely not a square. But it can be a square. Okay? You can make it, really slanted. Okay? Or you can make it straight up and down like a square. Those are all rhombuses. So a square is always a rhombus, but a rhombus is not always a square. Sometimes. Tomorrow you got 2 or 3 questions where it's always, sometimes, or never. And typically it's just going to be always or sometimes. Like in your work, if you look in the book tonight, it's usually just asking, is it always or sometimes? Okay? Alright, a rectangle sometimes is a square. Opposite sides are congruent in a rectangle. Well, opposite sides are congruent here, and it has 4 right angles. So a rectangle is sometimes a square. A square is always a rectangle. No. Is it? You tell me. What do you think? Is a square always a rectangle? Does it have opposite sides that are congruent? Does it have 4 right angles? It is always a rectangle. But a rectangle is not always a square. I'm trying to get you to think. Okay. A rectangle is not always a square, but it can be sometimes. Okay? Just like that can be changed a little bit. This can be shortened so that all 4 sides are the same. It's still a rectangle because it has 4 right angles. Okay? Alright. Now, that thoroughly confused you. Now we need to practice a little bit. Let's go over and make sure we understand all of the corollaries that you have in front of you. Okay? Alright, so these 2 corollaries we've already talked about. A rhombus, a quadrilateral is a rhombus if and only if it has 4 congruent sides. A quadrilateral is a rectangle if and only if it has 4 right angles. Okay? Rhombus has 4 congruent sides. Rectangle has 4 right angles. Okay, let's keep adding to these things. A square. Sorry. A square. Quadrilateral is a square if and only if it is a rhombus and a rectangle. 4 congruent sides and 4 right angles. A rhombus and a rectangle. That's what makes a square. Okay? Down here, diagonals. This is the part we're going to get into that we really need to make sure we remember. Only in a rhombus do the diagonals meet at 90 degrees. And you say, well, wait a second, what about a rectangle? Is that 90 degrees? No. So in a rectangle, only sometimes. Sometimes only when it is a square will they meet at 90 degrees. Okay? Square and a rhombus, the diagonals meet at 90 degrees. So all four of these angles are 90 degrees. Got it? They're perpendicular. Okay. All right. The next one, right below it. What do you think that says? What about the diagonals? Yeah, no.
Opposite angles are congruent to each other.
Yeah, no, we knew opposite angles are congruent to each other, but what is this picture really saying about the diagonals and those angles?
Opposite your angles.
They're bisecting.
Yeah.
So these two angles are identical, those two angles are identical, these two are identical, and those two are identical. They bisect the angle in a rhombus. Okay? Not necessarily in a rectangle. This is not the same as this angle. Okay? So only in a rhombus or square. In a square they will as well. Okay? In a square, your diagonals will bisect those angles, but not in a rectangle. Only when the rectangle is the shape of a square. Okay? You're writing this down in your notes? That's what I said in notes. Okay? Just so you get that. All right. Right fast. Okay. Now let's look at this extra practice. This is really good because this goes right into what your homework type of problems are like. Okay? Let's read it. For any rhombus, there's no picture here. Draw a picture. Draw a rhombus. What do you know about a rhombus? All the sides are congruent. That's all you know. And what about the diagonals? We'll draw the diagonals if we need to. So decide whether the statement MO is congruent to NP. Well, where's MO and NP? Well, you got to look at the order you have here. Ryan, you are sitting over there, dude. Get up and move over there.
I just moved.
No, you sit over there, where you're supposed to be. Okay? MNOP. Thank you.
Yep, no problem.
MNOP. Start at a corner and either go clockwise or counterclockwise. It doesn't matter. Start anywhere you want. Now I'll just do this. MNOP. Just go clockwise or counterclockwise. Don't mix up your letters though. Now answer the question. MO. Oh, MO is a diagonal. And we know the diagonals bisect each other. We also know that they hit at 90 degrees. Okay. Is MO congruent to NP? Always or sometime? Are the diagonals equal? Always or sometimes is the question. Are they equal here? Let's see here. A rectangle is a rhombus. Those are equal. A square is a rhombus. Those are equal. I'm trying to draw this a little bit extreme here. We're going to make a really big slant for this rhombus. Are you telling me that diagonal is the same length as that one? No. So only sometimes. Sometimes. Okay? Sometimes is your answer. Be very careful when you're practicing, that you pay attention to what you've been told. Rhombus. Now we're going to draw a square. PQRS. A rectangle. Sorry. And draw a drastic one, even though rectangle can be a square. Okay? PQRS. Again, just pick a corner and go around. And now, look at these angles. PQS. PQS. Oh, we need a diagonal here. So, we're talking about that angle right there. PQS. and then draw RSQ. RSQ. Okay, so we don't need to draw the other diagonal. We're asking about these two angles. Are they congruent to each other? And how do you know? Always or sometimes?
Sometimes.
I hear always and sometimes. Always and sometimes. The answer is always. Here's why. Aren't rectangles parallelograms? Parallelograms. I mean, you have two parallel lines cut by this transversal. These are alternate interior angles. Alternate interior angles are always congruent to each other. Always. Okay? Good? Always. Now let's go down. Keep looking at these. Okay. Always make sure that the given information is marked on your picture, okay? BCA. BCA is 44. That's what it says. AB is 9. And AE is 7. This is a segment. Now, always look to see what figure you have. A rhombus, a rectangle, or a square. What do we have? A rhombus. Now, before we even start, what do you know about a rhombus? What have you been taught so far? Just yell it out. What do you know about a rhombus? All sides are congruent. So this side, that side, that side, and that side. Anything else about a rhombus? What about the
Bisects.
what does?
The diagonal.
The diagonals bisect. So you know if that's 44, what's this one? That must be 44. Okay, good. And the diagonals bisect each other. They bisect the angles and they bisect each other. So if that's 7, what's this? 7. I don't know what this is yet. Okay, so that's about as much as we can do. And you should do that. So tomorrow when I give you a homework check, just check everything. Alright? BC. Raise your hand. What is BC? Rudy. 9. All sides are congruent, right? BC should be the same as AB. So BC is 9. Excellent. Alright. What about AC? AC is 14, yeah. The whole length here. If these two are both 7, then AC must be 14. Good job. And then the last one, ADC. ADC. Don't say 90 degrees because that's what it looks like. Remember, you're in geometry class. We don't assume. Romy? 44. Why do you think it's 44? Now, this is the angle it's asking for. ADC. So what's this big angle here? A good guess would be 88, but that is not true. But that would be a good guess. Okay? In a parallelogram, what you learned last week is that these are consecutive angles. What's consecutive mean? They'll add up to 180. Thank you. So if this is 88 degrees, tell me what this big angle is over here. Time.
Would be 92.
92 degrees. Notice they're only 4 degrees apart. It's very hard to look at a picture and see if and say that they're 90 degrees. Okay? Has to be exactly right. But you gotta remember the stuff that you learned last week, okay? Take that off. Let's do the next set. Alright. Again, what do we know about rectangles? It's parallel, yes.
So,
Go ahead.
All sides are, two sides are opposite. And
Opposite sides are equal, but they're not all the same, right? Okay? Anything else about diagonals? No?
you like opposite interior diagonals or
Alternate interior angles are congruent, that's true. What about the length of your diagonals in a rectangle? They're equal. So EG is the same as FH. It's hard to mark that one. But they are bisecting as well. It's parallelograms, so they do bisect each other. All right. Let's go through it. HFG is marked as 31 degrees. EG is 17. EG, that diagonal is 17. We know that right now. That's given. FHG. FHG. I want to know what this angle is. How would I go about finding that? Jaden.
Well, you know that EHI is 31.
That's right.
So you would take whatever the complete angle is and subtract it.
Okay, that's true. What do you know about that? All four angles in a rectangle that nobody mentioned. What are they equal? 90.
So
They're all 90 degrees. So if this is 90 degrees, that's 90 degrees, that's 90 degrees, that's 90 degrees. So if that's 90, then this is 59 degrees. You have to think a little. These are all puzzles. Remember those that we did a long time ago? HF. HF. What's that diagonal? Somebody said it. 17, because the other diagonal is 17. Okay? EFH. Let me erase this a little bit here. EFH. What is that angle? 59 degrees. Alternate interior angles, which we already talked about. Alternate interior angles. 59 degrees. Good. Not too hard, is it? Alright, and then the last three. Let's make sure we can get these. Again, what are we looking at? A square. Tell me everything about a square that you know.
All sides are equal.
All sides are equal. What else? All angles are 90 degrees. Yes, they're all equal. What do you know about the diagonals? They're perpendicular to each other, and the diagonals are equal to each other, and they also bisect each other, and they bisect the angles. It's a lot, isn't it?
yeah.
That's why squares are so special. They carry all those different traits with them. Okay? PK. Everybody by yourself, tell me by yourself what PK is. Write it down. Romy, what's PK?
You should have already said.
Oh yeah, what'd you write down?
I write nothing down.
Ian, what's PK?
1/2.
1/2. Remember the diagonals bisect each other. 1/2. Alright, on your own, PKN, angle PKN. PKN. Everybody write down quickly. Lucas, what is it? 90 degrees, yeah. Remember your diagonals hit each other perpendicularly, so they're all 90 degrees. And then the last one on your own, MNK. MNK. It wants to know this angle right here. Write it down if you think you know what it is. Like,
45.
Hannah? They both said 45? Why is it 45? Yeah, they bisect the angles in a square. So if it's 90, you divide by 2, you get 45 degrees. Good job, guys. Hey, that's it. All right, tomorrow you got about 6 questions taken directly from the homework assignment. Okay? Nope.